Now we want to figure out how long the ball is in the air. So remember, this x function is representing the horizontal distance, and the y function is representing the vertical height. So how long it's in the air? Well, it's in the air until y equals 0. That's when my height equals 0. That's when it hits the ground. So 0 equals negative 16t squared plus 189.1t plus 3. So at this point, I need to solve this quadratic. There's a couple ways you can do it. One way is by using the quadratic formula, which is great. I want to cut a little time, so I'm going to graph my equation. So I'm going to y equals negative 16t squared plus 189.1 t plus 3. So I want to find where this equals 0, so I can second calculate my 0. So when I look at this picture, I don't see a 0, so I'm going to zoom out. All right, there's one. Okay, so I want to second calculate a 0, which is number 2. Left bound is 0. Right bound, I'm going to say 10 will do. Oh, nope, that doesn't work. Second calculate a 0. Left bound is 0. Right bound, I'll say is 15 then. Now it's on the other side. You can see my arrow is now on both sides of the line. Press enter. So that's at about 11.8. So it's in the air for 11.8 seconds. So now number 3 is asking us, let me remind myself, when will it reach its maximum height? So the maximum height is when your ball goes up and stops and then comes back down. I'm thinking about how to do this. Okay, so that is going to be the vertex of this quadratic equation. So remember, to find the vertex, x equals negative b over 2a, and your height is f of x. So negative 189.1 over 2 times negative 16. So that's 189.1 divided by 32, really, which is about 5.9. So now I'm going to plug 5.9 into my y function. To see. So since I already have that plugged in, I'm going to calculate a value. I want to plug in x equals 5.9. So my maximum height equals 561.73 feet. So we have to recognize that our y value is a quadratic equation representing that projectile motion, and the maximum height is going to be the y value of my vertex.